Okay, so this lesson is titled Completing the Square. So what we're going to be doing in this lesson is we're going to learn how to change general form into this standard form. We're going to be going from general and we're going to rearrange it to look like that. Okay, the first thing we're going to do is actually the opposite. We're going to go from standard to general. Okay, that way is easy. It's this way that's harder. Okay, so what I'm going to do, I'm starting as a standard. I'm going to do this exponent. What happens when you square a binomial? So this is a binomial squared. I can't just square the x and square the 4 part. You can't do that in math. You have to square it as a unit. So that means the unit gets squared, because that's what squared means in math. Multiply it and multiply it again by itself, right? Does that make sense? Yeah. Here's the reason lots of people get it wrong, because they square each term individually. Because when I do this, it creates a FOIL. Okay? So the people that do it wrong by taking it individually miss out on the O and the I part of that. Okay, let's FOIL. First times first makes x squared. O means the outsides. So that is a minus 4x. I is the insides. So minus 4x. And L is the last times the last. 16. Positive 16. So those can now go together, right? Because they're like terms with each other. So I can say minus 8x. And I still want to do one more thing. What else do you think I would do to make it finalized?
Just type the 7.
Get rid of the 7. Okay, so that is that process. So it was just algebra. That was just algebra. So nothing new as a process. So this whole lesson is going to see us try to change it from the general back to the standard. Okay. So what we're going to do this, it's called complete the square. That's the method we're going to learn today. Okay, I got to take you through some warm-ups though before we get to this process. Okay, can you square this binomial for me? We need more practice squaring binomials. So what do you get? Can you square that? Squaring binomials doesn't mean square the individuals. It means to square the unit. Can you write me a trinomial that you get when you're done that? FOIL, FOIL, FOIL. Okay, did you get x squared? When you put some stuff together, did you end up with 6x? And the last was a plus 9? Okay? Everyone sees where I got the 6x from. If you did it, the outside was 3, the x, and the inside was 3x. Okay, can you square that? Okay, so I'm getting x squared, the minus 5x and the minus 5x, outs and ins, I'm putting together, and then a plus 25. Okay, did it work? There's a connection here. What's going on? The 3 has a relationship between those numbers in the same regards that the minus 5 has a relationship with this. So let's go here. What is the relationship between the number in the bracket and the middle of our trinomial? What did happen? It doubled. Yep. And look at the number in the bracket and then the last part. It gets squared. Okay, so that's the relationship that's going to always happen with that squaring a binomial. So what can you quickly discover that would be? What trinomial would that be? Using that idea of doubling and squaring.
X squared subtract 4x plus.
X squared plus 8x plus 16. Okay, so that's us just saying, hey, we kind of recognize the pattern of the FOIL, so we're going to cheat a little bit and do it faster. Okay, can you go the other way? So this time I gave you that perfect trinomial. So what would the bracket part have been? Plus 7. Because it's the number that doubles to that and the number that squares to that. Right? Okay, what about the next one? How are we getting x minus 10 does the doubling to 20, the squaring to 100. Okay, now I'm going to take you to one more stage. I want the number in the bracket, but then I also want to figure out what would have had to been in the last spot of the trinomial. So let's talk about what number would be in the bracket here. So x subtract 6, because I know the relationship of that would have had to double. So then the end would be a 36. So if I think about my bracket number on the next, x plus 9 is because plus 9 does the doubling to 18, and then 81. Okay, can I write a process rule here? So what did I do to get this 81? We took the B number, which was 18, then we cut it in half, which was what we got as a 9. We halved it, and then we squared it. Okay? Does that make sense? Because I knew the number I was thinking of has to double to 18, therefore I took the 18 and divided it by 2. 18 divided by 2, get it in your head, 9 squared. Okay. Now we're ready. So our goal was to take this and turn it back to this. That's our goal. Okay, so here is the process. There's an example. Step 1 is move the C. Move the C. So that would be if I have to move the number over. So y minus 9 Step 2 is complete the square. I'm just going to write it like that if you're okay. Complete the square. So this is what we just did. What number will go into that last position? So I did what and what to get there?
Equals 16.
16 because I took half of this because I knew my doubling number would have been, I'm using a -4, so that's taking half of it. And a -4 squared is 16. Okay? Then, step 3 is to balance this out. That 16, so I'm going to balance it. That 16 did not exist. So you can't do that in math. You can't just throw something into an equation because it's not going to be equal anymore. So because I'm on a teeter-totter and say I put 16 pounds on that side,
You're going to add.
so I have to add 16 onto that side. Okay? Don't get confused with algebra. This was a +9, so to get rid of it, I subtracted 9, right? That's an opposite operation. But this process is balancing a teeter-totter. So a teeter-totter, you need to do the exact same thing to keep it equal. Okay, step 4 is finalize. So we want it to look like that form on our paper. Okay, the example that I gave you right now, did you notice that the slope is 1? It's just a 1x squared?
Yep.
So in this, you don't have to write a 1 times something, right? Are you okay if I just kind of understand that that's not going to show because it's just 1? Okay, so final form would be y plus 7 equals, and then I have to have this as a binomial squared. So it's going to be x minus 4. Is that what we're picking? Remembering it's doubling and it's squaring. That's what that number is doing. Look at that, we did it. That was our original. Up here, that was our original one, and then we turned it to that. Now we've turned it back. Okay, so let's try another one. Okay. Step 1. I'm not going to write down, but I'm just going to say this is step 1, is that you move it Step 1, move it. Step 2, figure out what would go into that blank spot now. Finish your own trinomial. We always want our own trinomial there. So are you doing this? Taking this, half of it, divide by 2. Got it? And then square that value. Did you put a plus 1? 2 divide by 2 is 1, and then 1 squared is 1. Step 3, we threw that in there. We created it. It wasn't there. So we need to balance the math teeter-totter out. And finalize is the step 4. So y subtract 4 equals something squared. And I also know my slope is 1, so I'm just not writing it again. Slopes of 1, we don't have to write 1 times something. Can you think of the value of the number that would double to that and square to that? Plus 1. Okay. Example 3. Now we're going to get a little harder. So what changed on this example? What's different looking now? The slope is not 1 anymore. So we're going to have a little bit more work to do. Okay, so step 1 is the same. So we're going to go move the C. Okay, step 2 is where everything changes. Step 2 is factor out the slope. That's where it changes. We didn't have to do that last time, right? Because we don't need to factor out a 1 in math. That doesn't do anything. Okay, so we're going to go y minus 30 equals 2 bracket. Okay, here's the point of this all. Every time we're doing this process, we're trying to make ourselves that perfect, simple trinomial. So that's why we're getting that 2 out, because we need a simple trinomial. Okay, so I'm taking the 2 out. That leaves me with just an x squared there. Taking a 2 out, and when I'm saying taking it out, do we understand we're dividing it out? So this would become minus 8x. Do we see where I got that from? If it helps, you can multiply and see if it makes the original. Step 3 is now where you complete your simple trinomial. And this is so important to remember, that your goal is to get that simple trinomial. Okay? So don't ever complete the square unless you're doing it with a simple trinomial. I'm saying this a bunch because I get a lot of mistakes and people write me plus 64 on this question. That's not at all what you're doing. Do not think to write a plus 64 at the end of this because you can't work with that because that would not have been a simple trinomial. Okay, so this is where I am. What number would go on that blank to finish this? So half of this number? 16.
Plus 64.
Okay, step 4 is balance. So these other steps are the same. So we're going to balance it out. Okay. We're going to balance it on the other side with the teeter-totter, but your answer is that you are not adding 16 to balance it out. You're not subtracting 16. You're adding 32.
What?
Yeah. Because think about this. What do I really have? I have 2x squared minus 16x, which all existed. And this is really a plus 32, which is not on that line above. So that's what I need to balance it out.
Yeah, exactly.
Do we see it now? Like that I have those values in there? Aren't those values? Those values are all doubled.
Exactly.
Okay, step 5 is the same. Final form. You remember what it needs to look like? So on your little formula sheet, we know that it needs to look like this at the very end. So y plus 2 equals 2 bracket squared. Needs to look exactly like that. X subtract 4.
Exactly. Also, is the test going to be like on everything like this and like also do the graph stuff, the weird things? No? Okay.
And we still have word problems.
That way, we need to give it a break. Yeah, how long is this test going to be?
Like an hour.
You say that. If it takes longer than that, I'm going to take it. What's the test?
I'm not sure if we're going to get it in next week.
No.
Because you will not have me for math on Friday of next week. Because you're going to have an assembly during that period.
There's an assembly next week.
Next week, Friday, we're having a mental health speaker coming in. He's a comedian. Yeah.
Comedy.
So I think that's a period. Yeah. So I'm not sure if we're going to get it in by Thursday, and then if not, it might fall after that weekend. Okay, let's do number 5. Okay, ready? Step 1, move the digit over. So y plus 17. You don't have to write these all separate. Some of you might be doing that and other stuff at the same time. I'll do it one at a time just so you see what I'm doing. Okay. Right here is the moment of, are you going to make the common mistake or are you going to do the right step? What's the common mistake at this point? Trying to do the square part right now. That's a big mistake. I can only do the squaring stuff on a what? Simple trinomial. Is this that? No. Therefore, I need to take the -4 out. So this is going to be my simple trinomial. I need to make a trinomial now. So if I take the -4 out, now this is a 1x squared, simple. Okay, what happens to this second term? You're dividing it by -4. -4x. Now I can finish it up. So now this is where I create my own value. So what are we doing? Divide it by 2. Got that number? Which is -2. And now square that. 4. Okay. You're going to balance it, but you're not putting a add 4 on the other side. So what do you have to change the other side by? I'm going to have to subtract 16 because I have to remember whatever this number is, it is also multiplied by -4. So that's a -16, so now I'm -16 on that side. Last step, finalize it, so y plus 1 equals the slope. So I'm looking at my formula sheet. So y plus 1 equals the slope bracket x minus 2.